Hello and welcome to our new videocast for the release 21.10. Today I'm going to present the most important news of our static analyzers Astrée and RuleChecker. This time I grouped most news according to the features in the different views. As you will see, we worked hard to give you a lot of new features and enhancements in this new version. Let's start with the findings view. We added two new columns to the findings view, which are hidden by default. The weight, which grades alarms according to their significance, and the original source code location of the finding. The additional information can be added via right-click on the column header and selection of the corresponding entry. As you can see, the original source code location is now added as an additional column. The attribute weight can be added similarly. Alarms without calculated weight get the default value of 100, which is displayed in light gray color. In the overview filter view, it is also possible to filter the findings according to their minimum weight. We now have two less alarms in this view here, since we have two alarms with weight minus 100. This leads me to the new Save button in the filter view. It allows you to store the filter settings persistently. Persistent filters are reapplied when reopening the analysis project at a later point. Those filters can also be exported to DAX by setting the checkbox Result Overview Filter in the Export dialog. Let's move on to the graph view, which we redesigned and restructured. It can now show complete and partial call graphs for any function in the analyzed program. It is also possible to display thread-specific control flow graphs. Completely new is that the graph view is now also available in RuleChecker. Additionally, we updated the files view to be able to show the files in a directory tree. Let me show you these exciting news in the tool itself. Here we see the call graph of our Astrée project. In a concurrent project, at the beginning the sequential graph is shown, but it is also possible to display thread-specific control flow graphs. All the graphs can be interactively explored and are linked with the code and the findings view. When right-clicking on a node, I can select Show Call Graph for Function. Then the graph only shows the relevant path to the selected function. I have now opened a RuleChecker project. Here we see that in RuleChecker, under Results, we now have an additional entry call graph. When we click on it, the call graph of the project opens. It displays the whole control flow information collected during the analysis on syntactical level. Only calls that cannot be detected accurately on this level, such as calls via function pointers, are omitted. You can select graph nodes and show the relevant graph of the function you are looking for. In the lower view, you have all functions of the project as a list, and they can be selected to get more information about their call history. If you are looking for a specific function, hit Ctrl F in this view and the search will open. Clicking on this function again shows only the interesting path to and from this function. The caller-callee relationship, which is used for the call graph, is now listed in the Control Flow tab in the overview. This leads me to the Files view, which we enhanced for better visibility in huge projects. When right-clicking in the view, the context menu now contains an entry to switch between tree and list view. Using the tree view, you can easily find files located in the same folder. Now, looking at the identifier search, you will see that we restructured it to a hierarchical order. This leads to a fast overview on the possible search entries and a quicker workflow in this view. Additionally, we enhanced the search possibilities. As you can see, the identifier search now distinguishes between enumerator declarations and enumerator uses. It now also reports the definition and uses of preprocessor macros. And also lists uses of type names. Since we're already in the tool, I can show you the news regarding the tooltip information. The availability of tooltips is now indicated by dotted underlining, as we can see here. This has been added to improve the visibility of tooltip information, particularly in the C++ mode of Astrée. Now, getting to the options view, we have 4 new options for automatic filtering of assembly code from the source code for the analysis. This automatic filtering will save you time you can spend on other parts of the analysis. The new option Filter Pragma ASM replaces the former means ignore #Pragma ASM blocks via the checkbox in the configuration parser view. The new option Filter ASM Preprocessor Directive filters assembler code delimited by #ASM, #and ASM, and is enabled by default. The new option Filter Pragma Inline ASM filters the body of functions declared with #Pragma Inline ASM and is also enabled by default. The new option Filter ASM Function filters the body of functions declared with the keyword ASM. The new option only applies to the C frontend and is enabled by default. The analysis now also has a new phase in which it runs checks provided by the Clang static analyzer. It is disabled by default and can be enabled by disabling the option Skip Clang static analyzer phase. Additionally, we enhanced the AUTOSAR converter in the preprocessor view. You can now find the AUTOSAR configuration in this new window when clicking on this Tools button. As you can see, we grouped the different options in several tabs. The General tab displays the view you already know from older versions. Here you can specify your configuration files and select whether the default entry point or a generated analysis wrapper should be set as analysis entry function. What is new in here is that in the ISR tab, it is now possible to specify whether ISRs may be nested. Non-nested ISRs are treated as non-preemptible. And it is now also possible to specify priorities for ISRs by selecting the checkbox and adapting the priority in this view. Looking at the Astrée directives, I can tell you that we added a new directive Astrée partition calls, which partitions function calls in any declaration or statement before which it is placed. This leads me to the last point of today's video. RuleChecker now supports macOS ARM64 as an operating system. And as an early release, we enhanced the coverage of our rule sets. The C++ rule sets got lots of new rules and corresponding checks. The overview about the enhanced rules is shown on the slides and of course on our website. As always, we have much more news than I can show you in this video. If you want to see the complete list of changes or have questions, please visit our website www.absint.com or write an email to info@absint.com.